Kinetics, thermodynamics, and equilibrium. Below are the topics we're going to be looking over. So here is an introduction to each one. We're going to cover the basics of kinetics, thermodynamics, and equilibrium. You should reference back to this page when you're reviewing for the test over this unit. Make sure you comprehend each of these concepts. So let's start with kinetics. Kinetics is the study of the rate or the speed at which reactions occur. Which makes sense. We've talked about the kinetic molecular theory, talking about the speed of the molecules. So kinetics in general is the speed of reactions. Now, what is a reaction? Specifically, a reaction is the breaking and reforming of bonds. By reforming bonds, we're making new compounds called products. We know this from whenever we did delta H, bonds broken, minus bonds formed. So that was the reactants. We take all the energy required to break the bonds of the reactants, subtract the energy released by forming the new bonds. So a reaction mechanism, then, is a step-by-step process needed to make a product. It is the step-by-step process of the reaction. It's going from point A to point B, going from the reactants to the products. And this is just like when we bake a cake. You must follow the instructions. You can't omit steps, can't change the order, and you can't omit any reactants. So this is breaking down a reaction to see how do we really create all of the different steps of breaking down my reactants and producing all of my products. So let's look at why knowing the speed of a reaction might be important. For each of the following, determine whether each of these would be considered fast or slow, and why knowing this would be significant. For example, we know that rusting is slow. And why would this be important? Well, if you're in a shipping industry, this can be something that slowly creeps up on you. If you have this rust occurring, then this can cause damage to your ships, which can cause damage to your bottom line. So knowing that it's a slow occurring thing is something you have to keep your eyes out for. Complete the rest on your own. So what determines the rate of a reaction? Well, one, we have a number of steps. The more steps we have, the slower the reaction. And of those steps, you will specifically have a rate-determining step. So it is a step that will determine your rate. This is going to be the slowest step of the reaction, and it is the most important factor that influences the reaction rate. So if we were to do a visual representation of the speed of a reaction, overall my reaction is A plus B plus C makes ABC. However, this really breaks apart into A plus B makes AB, and then AB interacts with C to make ABC. To visually represent this, we have A and B uniting. When A and B unite, this is a slow process. It has a lot of activation energy. So if it takes a lot of energy for these two to combine, then this occurs very slowly over time. And then as this is slow, once we have an AB, if this AB interacts with a C, we break the bonds around the C and the AB to combine to form our ABC. This is quite quick and has a very low activation energy. So what our rate determining step is this right here, the thing that takes the most time to occur. Once we have the AB, it quickly combines with the C. So this is what we call a reaction mechanism, where we break apart each of the steps. Our overall reaction is A plus B plus C makes ABC, but this wouldn't really occur in this instance. This would require A and B and C all hitting each other at the exact same time with the right amount of energy in order to create this molecule. Instead, A and B will hit each other, then AB will hit C to make ABC. This is our reaction mechanism, breaking it apart step by step, and then our rate determining step is whichever one takes the longest time to occur. So I was just talking about A plus B plus C having to collide for the reaction to occur. This is based off of the collision theory. In order for a reaction to occur, reactant particles must collide. And when they do collide, they have to have the following for the reaction to occur. So first off, they have to hit. So they must collide into each other. Once they collide into each other, they have to have enough energy. That's going to be the activation energy we'll discuss more of. And they have to have the right alignment or direction or orientation. They have to hit in the correct alignment in order for them to switch off, breaking their current bonds and creating new bonds. We know it requires energy to break bonds. That's why they must have the proper energy. And the proper alignment is if that energy happens in the wrong place, it still won't break the bonds. So particles are hitting each other all the time in the air around you, but we don't have chemical reactions occurring in the air around you continuously because they must hit, they must have the right energy, and they must have the proper alignment. So only when particles collide with these conditions is there called an effective collision, meaning they collide and a reaction does occur. So there are 6 factors that can increase the likelihood of this happening, meaning increasing the rate of the reaction. The first factor is the nature of the reactants. Ionic substances will react faster. Covalent substances will react slower. Now why? Well, ionics are smaller. They're just individual ions. So there's less bonds to break and therefore less steps. So if I have this reaction occurring here, NaCl plus AgNO3 makes NaNO and AgCl. The only collision that has to occur, especially because these are aqueous, is I need to have a Cl and an Ag collide. There's only one of each. They need to collide in the correct arrangement with the correct energy, and that will form AgCl. Since these are an aqueous solution, it's very obvious because these ions would just be floating around and they don't actually form compounds when in an aqueous solution. That's why they're soluble. So all we need is this one very quick collision and we've made our product. For covalence, it's a different story. Covalent molecules are larger, so there's more bonds to break and therefore more steps. If I have CH4 plus O2 makes CO2 and H2O, our normal combustion reaction, in order to break apart this and this, I have to break 4 bonds here and 1 here. Then I have to form 2 bonds plus 4 here. So I'm breaking 5, forming 6. That's a whole lot different than just forming 1 bond here. So ionics are quicker than covalents. Next, we have concentration. This should be logical. If we increase the concentration, we increase the reaction rate. Well, we have more particles in a given space. So if I have less space between the particles, they're more likely to collide. If they're more likely to collide, then we're more likely to have effective collisions. So the reaction will occur faster. Next, we have pressure. Now, this one only affects gases. But if we increase the pressure of a gas, then that'll increase the reaction rate of the gas. Why? Well, because if we increase the pressure, that's going to decrease the volume or the total space in which these particles are taking up. If we decrease the space the whole particles are taking up, that decreases the space between the particles. And if they have less room in between them, there's going to be more collisions. More collisions means more effective collisions. More effective collisions means a faster reaction rate. Next, temperature. If I increase the temperature, that will increase the reaction rate. Well, they're going faster, so there's more total collisions. They're just going to hit each other more often. And when they do hit each other more often, they're also going to have more energy. So they're more likely to have the required amount of energy for the reaction to occur. That will create more effective collisions, faster reaction rate. Surface area. If I increase the surface area by making the pieces smaller, then the reaction rate will also increase. The question you need to ask yourself here is how many surfaces are there? Meaning, how many places are there for these collisions to occur? So by increasing the surface area, this exposes more reactant particles. It exposes more places for collisions. If there's more locations for collisions, there will be more collisions. More collisions means more effective collisions. More effective collisions, faster reaction rate. And last, we have a catalyst. A catalyst speeds up the reaction without changing the nature of the reactants or the products. So all that this does is it provides a shortcut or an alternative pathway for the mechanism. This lowers the activation energy. Now we're going to look at energy diagrams and talk about catalysts a lot, but the important part here is it's going to lower the necessary energy for an effective collision. So if that makes effective collisions occur more often, more effective collisions, faster reaction rate. Read through these detailed notes to make sure you have a very firm understanding of each of these concepts. Show me that you read them. Highlight, underline, give some annotation, ask some questions. You have 9 review questions over this topic. They are all pretty much directly from the notes, so you shouldn't have any difficulty. But if you do, ask me questions on Edmodo or email me.